Good evening, ma'am.
Yes, hello, good evening.
Good evening, ma'am.
Yes, good evening. So I think we should start now. Today I want to start the new chapter, that is probability. So how was the test yesterday? Have you all submitted your test, Hamna and Vidula?
No, ma'am, I have not submitted it.
Why?
Ma'am, tomorrow I'm not fine, ma'am. Ma'am.
So have you given the test yesterday?
No, ma'am, I will give and send it.
But you were supposed to finish it yesterday only. And what about you, Hamna?
Yes, ma'am, I did it.
So have you submitted?
No, ma'am.
But why? I mean, this was a test. You were supposed to submit it. You will get it checked. Please submit it soon.
Okay, ma'am.
All right. Now, the next chapter is called probability. Okay, in your own language, what do you understand by the term probability? Hamna. What do you understand by this term? What idea does it give you? Yeah.
Like chance of something, any chance.
Yeah, chance of happening something. Yeah, right? Yes. Mridula, any other answer? Yeah, okay. So in a normal language, Hamna is right. We can say the chance of getting some answer, getting some outcome. Or I can write the extent to which something is likely to happen, that is called probability. Is likely to happen. For example, let us take an example of a coin. So you have tossed a coin, right? So there are some possible outcomes. Oh, wait, Miraj has also joined. Yes. Hello, Miraj. Can you hear me?
Yes.
Okay. So have you submitted your test, which I took yesterday?
Ma'am, yesterday I did not join the class because of network problem.
All right. So you will get those questions. You have to complete them and you have to submit, right?
Yes, ma'am.
Okay. Now I've started with a new chapter, which is called probability. So first of all, we are discussing like in a normal, in your normal language, what do you understand by this term probability? So any idea can you give me, Miraj?
Possibly
Yes, possibility.
or maybe.
Yes, maybe chance of getting something, or I can write the extent to which something is likely to happen, right?
Yes,
Now,
ma'am.
example is you can take an example of a coin. So you have tossed a coin. So there are possible outcomes. You can get head, you can get tail, or you throw a dice. So you can get 4, you can get 3, you can get 1. All right. So now, so the chance, let us say in a throw of dice, you want to find how much is the chance of getting 3. So how will you find it mathematically, right, Mridula? So there's a formula by which we can mathematically calculate this number, that what is the exact, what is the probability of getting some possible outcomes. Now the formula is, I'm writing, please note it down. Then I'll explain the terms. E is basically event, which I'm denoting by E, right? Probability of getting this event is called number. This is the formula which you have to keep in mind, which we will use in this chapter. So number of trials in which E has happened. Divided by total number of trials. Please note this formula. You can write event here so that you remember in which event E has happened. Right. Now, have you written formula? Now, please note, in this formula, there are some terms which you need to understand. First of all, what is a trial? I mean, mathematically, what is a trial? And then what is an event? So you have to understand what is a trial and what is an event so that you can use them in this formula, right? Now, first of all, trial. Trial is basically an action which results in some outcome, okay? Please note these definitions. Trial is an action. So underline this term, action. Trial is an action which results in some outcome. All right. Now, when I'm saying action, so the example I can write is the throw of a dice, right? Throw of a dice. So what is the action here? Throw. All right. So I'm throwing a dice. This is an action. So you will get outcomes. You can get 2, you can get 3, you can get 4, 5, 1, 2, whatever, right? So the action of doing this Why have you muted your mic, all of you? I don't understand this thing. Please unmute your mic, both of you.
Ma'am.
Yes.
Ma'am, ma'am, in the definition of trial,
Hmm.
after reason, what is written
Is trial is an action which results in some outcome. Yes, Hamna, have you
I'll
written?
come in a minute.
Okay. Hamna, have you written?
Yes, ma'am.
Okay. All right. Also write the example, throw of a dice, toss of a coin. These are all trials. Now, what is an event? The next thing. Event is basically, when you get an outcome, like you have thrown a dice, okay? So what will happen? Now you will get some outcome. So the getting that outcome is called the event. You can write it here, getting an outcome. I'll explain these with the help of questions, then you will understand them better, but please note it down. So in an example, you can write getting head in a particular throw. Is an event. So you can write this in inverted commas, is an event with outcome head. Yeah, any confusion here? Yes, Miraj, have you come? Yes, Mridula,
Yes, ma'am.
any confusion here?
No, ma'am.
Yes, Miraj, are you there?
Um,
Okay, so please note it down. What is a trial? What is an event? And I think in this chapter, I'll start with examples. And after doing the examples, we will come to the exercise. So I'm starting with your example number 1. Just let me insert the question. So
Ma'am,
that
can
I,
you show the examples?
sorry, Mridula, what are you saying?
Ma'am, can you show the examples of event?
Wait, just give me a minute. Yeah, this is the example I have written here. Getting head in a particular throw is an event with outcome head. See, you have tossed a coin, right, Mridula?
Yes,
So
ma'am.
this is called a trial. Like the toss of a coin is a trial. Now you are going to get some outcomes, right? So the getting of that outcome is basically an event. So in that outcome, anything can happen. You can get a head, you can get a tail, right?
Yes, ma'am.
So this like getting the outcome of that trial is basically an event. All right.
Yes, ma'am.
So please write this sentence. It will make the definition clear. Now I'm going to explain all these terms with the help of questions. So that is why I'm starting with examples. Now the example number 1, which is given in your book, is here. A coin is tossed 1,000 times, all right, with the following frequencies. So you are getting head 455 times and you are getting tail 545 times. Compute the probability of each event. So let us write it like this first of all. So basically here there are 2 events. One event is getting a head, right, Miraj?
yes, ma'am.
Another event is you are getting a tail. Is this clear, Hamna?
Yes, ma'am.
So we are denoting these events separately. So let E or A is the event of getting head, right? And also let B is the event of getting tail. So I'm not writing the complete sentence. You can complete it. So these are the 2 events. Now we will calculate the probability of each event in this case. So first of all, let me calculate what is the probability of getting a head. So P of A, right? What do you understand? Or do you understand what is A now? A is the event of getting head. So I'm going to find the probability of this event A. Now, this is number of heads and divided by total number of trials. Now you match this formula with the formula I have written earlier. What is in the numerator? The numerator says,
Number of trials.
yes, numerator says the number of trials, right, in which the event has happened. So now what is the number of trials means number of heads, right? Now, how many times you are getting a head here? You are getting 455 times and the total number of trials are 1,000. All right. Now, after this, it's all calculations. Up till here, you have to understand what we are doing. Now you can do your calculations. You all know how to divide this. So simply put zeros in this case, you don't have to divide. 0.455. All right. Similarly, we are going to find the probability of the event B, which is basically getting a tail. So number of tails and divided by Total number of trials. So number of tails, how many times you are getting? 545 times, and total number of trials are 1000. So 0.545. All right.
Yes, ma'am.
Yes, Mehraj?
Yes, ma'am.
Now you can do one check here. What is the check? You just add the two probabilities, like probability of getting a head plus the probability of getting a tail. So what will you get? 0.455 plus 0.545. And if you add this, you will get what? So 5 and 5, 0, then carry 1, then 5 and 5 again 0, then carry 1, then 5 and 5 again 0, and carry 1, 1. So basically you're getting 1. All right. Now please note one thing. I'll explain it. Write a note. I mean, this is valid for all, like all cases, right? All questions. Note, the value of probability lies between 0 and 1. Always, right? Now, in this question, you are getting, if you add the probability of these two events, PA plus PB, you are getting the answer 1, which is very obvious because when you toss a coin, there are only two possibilities. Either you are going to get a head, right? Or you are going to get a tail. There is no other possibility. All right. So try to understand this thing here. Wait. See, you have tossed the coin 1000 times. Let's say 1000 times. What can be the chances here? Miraj, try to understand this thing very clearly. Like all the 1000 times you get a head, right?
Yes, ma'am.
Look, okay, head and a tail. I'm writing like this. So you are tossing them 1000 times. So there can be a possibility that you get, or like 1000 times you are getting head, so that you will not get any tail. All the 1000 times head only. Then the next chance, which is uh, like 455 times you are getting head, and then rest 545 times you are getting a tail. Now another outcome can be you don't get any head, but you all like all the 1000 times you get your tail. Is there any other possibility? I mean, these numbers can vary, but you can get something else here, or you can get something else here, but these types of cases will be there, right, Hamna?
Yes, ma'am.
Yeah. So in this case, now look here, in this first case, right? In this first case, what is the probability of getting head? So it is basically 1000 divided by 1000, which is 1, right? And the probability of getting a tail is 0 by 1000, which is 0. So in this case also, you will get 1 plus 0 is equal to 1. So you can see that you will not get answer more than 1 in any of the case. In this case also, if you add the two probabilities, you will get your answer 1. Is this point clear?
Yes, ma'am.
And if you get any other type of number, there also the maximum value of the probability is going to be 1, which we have already seen. So this was just to make you understand. All right. Miraj, any confusion here?
No.
Okay, it will further be clear in your mind with when I'll come to other questions. So the example number 1 you have understood. Let us now start with the example number 2. in this question, look here. Two coins are tossed simultaneously 500 times. All right. So you are having two coins both in your both hands and you are tossing it simultaneously. So these are the cases you are getting. Like two heads. I mean, both the coins are giving you head. So 105 times that is happening. Then you are getting only one head 275 times, and no head you are getting. I mean, you are getting tail in both the coins. So that is happening 120 times. So find the probability of occurrence of each of these events. So first of all, we are going to give name to all these three events. All right. So we will write it like this. Let A is the event of getting, two heads. You know, this is one of the event. See, two heads. This is one of the events. So we are calling this event A. All right. And similarly, let B is the occurrence of getting one head. You can complete the sentence yourself. And then C is the event of getting no head. Is this clear? So we have given names to these three events, right?
Yes, ma'am.
Okay. Now we are going to find the probability of the event A. That means getting two heads. So in both the coins, we are getting 105 times we are getting. And the total number of trials are 500. So what is the answer? So you first of all divide it by 5 so that you will get 100 in the denominator. So this is like 100 times and 5 means 21 times, right? So 21 by 100 and this will give you 0.21. Yes, Miraj? Okay. Now we will calculate the probability of the event B, which means getting one head. So you are getting one head 275 times and the total number of trials are 500. So again, you just divide it by 5. So this is like 5 into 5, 25. And then again, 25 means 55 and divided by 100. So this will be 55 divided by 100. It's going to give you 0.55, right? Okay, next. So the probability of getting no head, that is happening 120 times and the total number of trials are 500. So you again simplify this with the help of 5. So this is going to give you 5, 10 and then 20. So 24 divided by 100. This is 24 divided by 100 and this is going to give you 0.24. If you have any confusion, please ask me. I'll clear this at this stage only. Miraj, is everything clear?
Yes, ma'am.
Hamna, any problem?
No, ma'am.
Mridula?
No, ma'am.
Okay. Let us do the next example then. Now, this is the question. Now, what is it saying? A die is thrown 1,000 times with the frequencies of the outcomes 1, 2, 3, 4, 5, 6 as given in the following table. Have you seen a die, all of you?
Yes, ma'am.
Okay. Yes, Miraj, do you know what is a dice?
Yes, ma'am.
Okay, fine. So you have seen a dice. So basically it has some dots on every face, one dot, 2 dot, 3 dot, maximum 6 dots. So these are the cases. I mean, you are throwing your dice 1,000 times and then you are getting one. One means you are getting one dot, all right? So one dot you are getting 179 times, then your 2 dots you are getting 150 times, then 3 dots you are getting, it's like this. Is it clear? So these are the frequencies of getting the answer 1, 2, 3, 4, 5, 6. Now find the probability of getting each outcome, right? So first of all, we have to give name to every event, all right? The event of getting 1, then the event of getting 2, then the event of getting 3 dots, event of getting 4, 5, 6 dots, right? So in this case, you have 6 events. Is this clear? No response. This is
Yes,
your
ma'am.
event 1, this is your event 2, event 3, it's like this. So basically in this question, you are having 6 events. Now, in place of giving the names A, B, C, D, E, F, not like this, we are going to give the names like this. Let EI, so I'm putting a subscript I here. Let EI denote the event. Let EI denote the event of getting the outcome. Of getting the outcome I. All right, where I is equal to 1, 2, 3, 4, 5, and 6. Is this clear?
Yes, ma'am.
So basically EI denote the event of getting the outcome I, which means if you are getting the outcome 1, then I'm giving the name E1. If you are getting the outcome 4, I'm giving the name E4. It's like that. Is this clear? So first of all, let's calculate the probabilities. So probability of getting 1, so is equal to, so I can write PE1, all right, which is equal to like frequency of 1. That means how many times you are getting 1, or the number of times you are getting this event. Is this clear? Wait, in the formula I have written like this. Number of times of getting event 1, right, divided upon total number of trials. So the number of times of getting event 1 means frequency of 1. Can I write it like this? Frequency of 1 and divided by total number of trials. So now you put the values. So I'm getting 179 times. And how many times I'm throwing my dice? 1,000. Right? So this is going to give you 0.179. Is this clear?
Yes, ma'am.
Okay. And similarly, you can calculate the probability of I'm just using this space here. So now probability of getting my event 2. Then similarly, probability of getting my event 3, and then probability of getting my event 4, and probability of getting my event 5, and also the probability of getting my event 6, right? So the event 2 means frequency of 2 divided by total number of trials. So you will write it like this, frequency of 2 and divided by total number of trials. Now, what is the frequency of getting 2? You are getting 2 150 times. 150 divided by 1000. All right. And similarly, E3, you get 157 divided by 1000. And this is 149 divided by 1000. Then this is 175 times divided by 1000. And this is 190 divided by 1000. Now you can find the answers. Simple, you just have to put points here because you already have zeros in the denominator. All right, Miraj?
Yes, ma'am.
And this is going to give you 0.190. Right? Now, in this case also, you can do your check. What is the check here? Or you can like write a note or a check, whatever. So you can see that the sum of all the probabilities like PE1 plus PE2 plus P of E3 plus P of E4, probability of event 5, and then probability of event 6. So if you add all the numbers, you can just check it because it's already solved in your book. You will get the answer 1. All right. Because in the throw of dice, these are the only possible outcome, right? Can there be any other event in the case of a dice? See, either you will get a 1, either you will get a 2, 3, 4, 5, 6. So these are the only possible outcomes in the case of a dice. So if you add the probability of getting each outcome, you will get the answer 1. And as we have seen, the value of probability cannot be more than 1. All right.
Yes, ma'am.
Okay. Next question.
Ma'am, can you scroll a bit up?
Sure. Yes, written.
Yes, ma'am.
Okay, this is the question now. On one page of a telephone directory, there were 200 telephone numbers, right? Now, the frequency distribution of their unit place digit is given. For example, he's also explaining, this is the telephone number, right? So which number is there at the unit place? It's 3. So like that, okay? So these are the possible, these are the frequencies out of those 200 numbers. See, at a unit place, you are getting 9 20 times. Then at the unit place, you are getting 6 14 times. You are getting 3 22 times. Is this clear? Is this table clear?
Yes, ma'am.
Okay. Now, without looking at the page, the pencil is placed on one of these numbers. That is, the number is chosen at random. So you have closed your eyes and you are simply just scrolling your pencil and you have stopped at some number, right? So what is the probability that the digit in its unit place is 6? So you have to tell what is the probability that you get 6 at the unit place. So how we are going to do this? So first of all, right, let E is the event. First give a name to this event. So let E is the event of getting 6 at unit place. All right. Okay. So now we have to find the probability of this event E, which means frequency of 6. Frequency of 6 means you are getting 6 at the unit place and that is happening and divided by total number of selected phone numbers. Total number of phone numbers on that page. All right. So the frequency of getting 6 at the unit place is given in the table, which is 14. Can you see here? 14. So 14 times, 14 telephone numbers basically have 6 at their unit place. And the total number of telephone numbers which you have selected are 200, right? So now just simply do your mathematical calculations divided by 2. So if you divide it by 2, what will you get here? You will get 7 divided by 100 and this is going to give you 0.07. This is the answer. Please write it down. Yes, have you written?
Yes, ma'am.
Okay, next question. Yes, this is the question. The record of a weather station shows that out of the past 250 consecutive days, its weather forecast was correct 175 times, right? You get weather reports in your phone also. Sometimes it is correct, sometimes it's not correct. So 175 times it is happening that the weather forecast is correct. Now you have to find what is the probability that on a given day it was correct. And then second part, what is the probability it was not correct on a given day? Okay. So how you will do it? First of all, can we write, let's give a name to this event first of all. Either you can give name or you can simply directly write like this. The probability of the forecast is correct. This is the event. I'm not giving it some special name. I'm directly writing it here that the forecast is correct on a given day. This is the event, right? Or you can write it, let E is the event of getting the forecast correct on a given day. And then you can write PE. Is this point clear?
Yes, ma'am.
Okay, or you can directly write it like this. The probability that the forecast is correct on a given day. That means it is, how we will write it, the number of days when the forecast is correct and divided by total number of days. Total number of days. See, this sentence is looking very incomplete. Total number of days. I mean, which days I'm talking about, right? So I have to complete the sentence. Total number of days for which the record is available. Right, Maraj? I can leave it like this also, total number of days, but I should mention about which days I'm talking about. So basically the total number of days for which the record is available. This is the record of some meteorological department. So now the number of days when the forecast is correct is given 175 times and the data is available for 250 days, right? Now you simplify this thing. Divide it by 5 first of all. 5 into 3 is 15 and then 25. So 35 you will get. And here 50 you will get. Again you divide it. So you get 7 and here you get 10. So 7 by 10. So basically 0.7 you will get the answer. Am I right? Is this clear?
Yes,
Yes,
ma'am.
ma'am.
Okay. Written, all of you? Mehraj, have
Yes.
you written?
No,
All right.
ma'am.
Please write it quickly. Now, second part. Now look here carefully. You also have to find the probability that it was not correct on a given day, right? So basically, in the first case, we were supposed to find the probability that it was correct. So for that, we should know the number of days, right? For which the forecast is correct. But we don't know the number of days for which the forecast was not correct. So how can we find the number of days for which the forecast is not correct? How can we find it?
Ma'am, 250 minus 175.
Exactly. Right, Miraj? So total number of days are 250. And out of that, 175 times it's correct. So that means the remaining number of days, it's not correct. Is it clear?
Yes, ma'am.
So first of all, find the number of days for which the forecast is not correct. So this is equal to your total number of days, 250 minus 175 times. How much will it give you, Hamna?
Ma'am, 75.
75. So 75 on 75 days, you are not getting the forecast correct. So what is the probability that your forecast is not correct on a given day? So the probability that the forecast is not correct on a given day. on a given day, sorry, right? So this is equal to, now same number of days when the forecast is not correct, and divided by total number of days like for which the data is available. The data or record is available. As we have written in the earlier question. Right? So this is your 75 and divided by how much? 250. So now just simplify. What will you get? Tell me.
Ma'am, 0.3.
0.3. Right. So here also you can note or a check, you can write here that you can check the answer. Earlier case you are getting 0.7 and here you are getting 0. Prediction or you don't get the correct prediction. Right, Medula?
Yes, ma'am.
So we have found the probability of both these events and we have seen that the sum of the probability is 1, which is the maximum value, because these are the only two possible events possible. In case there is any other event possible, so you will not get your answer 1. Is this point clear? Right? Okay, let me explain this point again, which I'm saying. Please note. Miraj, please note carefully. Amna, Mridula. See, let's take an example of a dice, right? So you can get 1 dot, you can get 2 dots. So I'm instead of dots, I'm writing 1, right? You can get 1, you can get 2, you can get 3, 4, 5, and 6. So these are the 6 possible events which can happen, right? Now you're calculating the probability of getting 4, let's say, right? Of event 4, I'm saying. And let's say you are getting 0.2. For example, this is just an example I'm giving. And now you have found the probability of getting 6. We have found the probability. Look here, we have only found the probability for this particular event and this particular event. So that is why my sum of the probability is not going to be 1. Is this clear?
Yes,
Because there are other possible events in this case. Miraj, is this clear?
Yes, ma'am.
Yes. And as in the case of this previous question, there can be only 2 possible events, correct prediction or not correct or incorrect prediction. There cannot be any other possible event. So that is why my sum of the probability was coming out to be 1, because I have included all the possible events. Is this point clear?
Yes, ma'am.
Okay. Let's do one more question. We have time because we already started 5 minutes late. Now, here is the question. A tire manufacturing company kept a record of the distance covered before a tire needed to be replaced. Okay, so the table is showing the result for 1000 cases. So try to understand the table first of all. So basically less than 4000 means, before covering 4000 kilometer, the tire is required to be changed. All right, so that is happening 20 times. And then the tire has already covered a distance from 400 to 9000 4000 to 9000 kilometer. And like after covering this much distance, it is required to be replaced. So this event is happening 210 times and like that. Is this clear?
Yes,
Yes,
ma'am.
ma'am.
Now, if you buy a tire of this company, what is the probability that it will need to be replaced before it has covered 4000 kilometers? So basically this event he is talking about, first one. All right. Okay. So let us try to find out the probability, how I'm going to write it. So the probability of you can take the sentence from this question that the tire need to be replaced. So write this because this probability we are finding out, right? So the probability that the tire need to be replaced before it has covered 4000 kilometers. So this probability I'm finding out. I've taken the sentence from the question itself here. Now, what this is going to be equal to? So what is the frequency of changing the tire before 4000? 20, right? So 20 and divided by, you are discussing 1000 cases. So 20 divided by 1000, which is equal to, so your 10 will get cancelled out. So 2 by 100 you will get, which will give you 0.02. Is this clear? Is this clear?
Yes, ma'am.
Okay. Miraj, have you written?
Yes, ma'am.
Okay. Now next part. Look here. What probability you have to find? That it will last more than 9000 kilometer, right? That the tire is going to be last more than 9000 kilometer. Now you don't know the exact number because this, look here carefully. This particular is giving you from 9000 to 1400. All right. And this is more than 1400. And in the question, it is saying more than 9000. So basically, this is also included and this one is also included, isn't it?
Yes, ma'am.
Because more than 1400 is also more than 9000. Yes, Miraj?
Yes, ma'am.
Okay, so that is why in this case, first of all, we have to find that, first of all, we have to find the frequency. The frequency that the tire will last more than 9000 kilometers. So that frequency will be equal to this frequency 325, which is 9000 to 1400, and also, sorry, where's my pen gone? Here, wait. Yeah, so plus and more than 14,000 also, 445. So this is going to give you how much? 550, then sorry, yeah, 1 and then 7 and then 7, right? 770. So basically, you have to find the probability for this particular frequency. Now write probability that the tire will last more than 7,000 kilometers. No, 7,000, no, 9,000 kilometers, sorry. So the frequency of happening this is 770 and the total number of cases are 1,000. So you will get the answer 0.770. Is this clear? Please note it down quickly. Yeah, Miraj, have you written?
Yes, ma'am.
Okay, next, third case, which is again interesting. Now, it will need to be replaced after it has covered somewhere between 4,000 and 1,400. You know, this is actually more than 1,400. So you don't have to include this, right? This is 4,000 to 900. So you have to take this. And this is 9,000 to 1,400. So you have to take this also, right? It is saying between 4,000 and 1,400, 14,000 kilometer. Is this point clear?
Yes, ma'am.
Yes, ma'am.
Yeah, so you don't have to take the frequency of more than 14,000. So I'm just leaving this part for you. It's already done in your book. So first of all, you will find out the frequency that the tire will last between 4,000 to 14,000 kilometers. So you will be doing 210 plus 325 and then you will find its probability. Can you do it?
Yes, ma'am.
Okay. So I think that's it for the today's class. The rest of the examples and the exercise we will be doing on Thursday, right?
Okay, ma'am.
Okay then. Okay then.
Thank you.
Bye. Good night. Bye. Thank you.
What do we have to add?
Yeah, I mentioned. See, Amna, the third part, somewhere between 4,000 and 14,000 kilometers, right?
Yes, ma'am.
Yeah, where's my pen gone? Wait. Now look here. This is 4,000 to 9,000, right?
Yes, ma'am.
Thousand. So basically you have to add these two frequencies, 210 plus 325. Is this point clear?
Yes,
Yes, ma'am.
ma'am.
Okay. So you just add these two frequencies and then you have to find the probability of getting this particular event. Okay then. Bye. Any other question?
No, ma'am.
Okay then. Thank you.
Thank you.